Okay, let's go. Right, this is the last section of this unit. So we will, next class we'll review and then we'll test on Monday.
Wait, Mr. Callahan, the quiz and all the stuff you guys do in the past few times.
Yeah, it doesn't have the direct variation stuff on there.
It's just like the graph.
Solving for y and graphing slope-intercept form. Okay, quiet please. Quiet. So, remember what it meant, we did in the first chapter, first unit, what it means to say that something is a function, right? If something is a function, that means for every input you get one output. Or sorry, yeah, you get one output. You can't plug in one number and get two answers. You know, functions only give you one clear answer. If we saw in a table of values, that meant you had no repeated x values. You all remember that? No repeated x values. In a mapping diagram, you know, mapping diagram was something like this. Right? 1, 2, 3, 4, 5, 6. You know, if you have more than one arrow coming from a member of the domain, which is on the left, then you're going to say that's not a function. That's like having a repeated x value in a table of values. Now, the one part I don't think we did much in this class is what if you're looking at it on a graph, right? If you're looking on a graph, you're supposed to apply what's called the vertical line test. A vertical line test means that you can draw a vertical line on the graph and it would never intersect more than one point. So if I look at these are discrete because it's just a bunch of points. It's not a continuous line. And then the one on the left, you could see every one of those points is on a different vertical line. So there's no way you draw one vertical line and intersect two. But look at the one on the right. In fact, I could, if I drew a vertical line here, it would intersect two places. That's why it's not a function. Okay, so that's called the vertical line test. Now, if we have a continuous graph, and at this point the only continuous graph we know are straight lines, something like on the right, I mean, you can't draw a vertical line through every point on that graph, because how many points are there on the graph? Yeah, all you can do is just kind of imagine. Can you imagine anywhere on the graph on the left that you drew a vertical line? Would it intersect in more than one place? No, every vertical line, you know, would just go once. There's nowhere you can imagine that happening. I mean, the only time you really see this where it fails, it's like if you have a function that looks like that. Okay, then a vertical line crosses in two places, not a function. Now, when it comes to straight lines, the vertical line fails a vertical line test, right? Because how many places does a vertical line intersect a vertical line? Infinitely many, right? If I draw this vertical line, right, I'll draw it in red so it's over the top of the blue. Every point on one is on the other. So, I mean, all we need is two and it fails the test. So a vertical line fails a vertical line test. Right. But every other linear equation is a vertical line. Is a function. Every other linear equation would pass a vertical line test and would be a function. So the equation of a vertical line, if you remember, starts with x equals, right? X equals is how you make it, how you name a vertical line. All the other linear equations are going to start with y equals. And you know, if you look at the calculator on the top left, it's got that y equals button. You just think of that like that's the function button. That's where I put functions. So that could be like a test question, something like, are all linear equations functions? True or false? All linear equations are functions. No. Give an example that it's not. Of a linear equation which is not a function. No, a vertical line. Say x equals 2, x equals 3. There's an example. Okay, so now we did this kind of stuff already. Like if I want to find the value, here's a linear equation, y equals 3x minus 2. Find the value of y when x equals 2. What are you supposed to do with the 2? Right? You're supposed to put the 2 in the place of x there. Right? And then simplify. Y equals 3 times 2 minus 2, which is 6 minus 2, which is 4. Right? So this is the long way around to get to this point. So now we're introducing something we call function notation. Function notation, in function notation, you replace the y with f parentheses x, right? And that little lowercase f you could think of as standing for function. That means what follows here is a function. F of x, or f parentheses x, you read it like that. You say f of x, right? That's how you say it. It's not f times x, it's f of x. You cannot split the f from the parentheses x, right? They go all together. That's called function notation. So we already did this one. If y equals 3x minus 2, find y when x equals 2. We substituted x equals 2 and we solve for y. Using function notation, what you would say is find f of 2. Right? F of 2 means replace in this expression whatever number's in the parentheses there, put that in the place of x on the right. So it's actually doing the same thing that we did at the top, but that's doing it with function notation. Right? So, in fact, you would probably say it like this: evaluate f of 2. Now, what did it mean before when we said evaluate? Remember, evaluate was when you got an expression and they gave you the values of the variables and you had to substitute and simplify. That's what we're doing here. So actually it's something you'd be able to do using whatever we did in the past. I mean, at this point it's just all linear stuff, but it could be more complicated because the whole idea is just to understand what do you do when you have f parentheses a number. What are you supposed to do with that? So here's an example. Oh, where's that not go? So find f of negative 3 if f of x equals 3x minus 15. Again, you're supposed to put whatever's inside the parentheses here, it's going to go inside the x there. F of negative 3 equals 3 times negative 3 minus 15. Simplify, right? Negative 9 minus 15. So f of negative 3 equals negative 24. Right? That's how you evaluate a function. Yeah, Hunter?
For your final answer, if you put f of x equals negative 24, would that be wrong?
Yes. F of x, because the x is still there, that's got to have an x in the expression. So you want to say f of negative 3. Okay. Okay, so you try. Find f of 7 for that one. So f of 7. Again, what do I do with the 7? Right? Since we replaced x with a 7 there, we're going to do the same thing here. So f of 7 equals negative 49 plus 4. Which is negative 45. So how many say that's easy? Easy stuff, right? Now, here's where they change the question up a little bit. You got to be paying attention and not just trying to do whatever you just did on the last one, because there's still too much of, on your homework, you get to a certain set of problems, you just do whatever. It has nothing to do with the directions, right? In this case, they're going to say, here's the value of f of x. Now you find the x, right? Find the value of x so that f of x equals 6. That's not saying find f of 6. They're saying this whole f of x could be replaced with a 6. And now solve for x. And that's a two-step equation, right? What are the two steps? No, you're solving for x. Add 10, then divide by 2, right? So add 10. 16 equals 2x, so x equals 8. So remember, keep it straight. You know, if they say find f of a number, then you plug it in there. But if they're saying find x so that f of x equals something, that's not saying find f of a number. So try that one. Find the value of x so that f of x equals 8. Okay. What property says I can switch the sides like I just did? No. Symmetric. Okay, one last example, and then we're going to take our quiz. Okay, the gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x, that is the number of wolves, equals 37x plus 7, where x is the number of years since 1995. Graph the function and state the domain in the range. Okay, so let's see. If x is the number of years since 1995, then what year is represented by x equals 0? 1995. That's the beginning of this thing, right? And so if I plug in x equals 0, what's the value of f of x? 7. Okay, what year would it be if x equals 1? Now, what year is it when x equals 1? Somebody said it. 1996. It's 1 year since 1995, so it's 1996. If I plug in a 1, Adam, what do I get? F of 1 equals 44. Now, if you saw this example in the book, they had more points than that, but how do I know that this is a linear equation? We've gone over this. It's going to be a test question. Everything's to the first power. How many points do I need to determine this line? You only need 2. So they could have more, but the truth is we only need to have 2, and that's the line. That's why I only included 2. So at 0, I'm going to go to 7, and at 1, I'm going to go to 44, which is about there, and this is the graph. And I'm going to make it... Right now, the arrow only goes one way, up and to the right. So what would we say is the domain? Where do the x values start? Okay, the x values started at x equals 0, and they went to the right. Where do the y values start? 7, go up. Okay, so how can I use inequalities to say that? X is greater than or equal to 0. Y is greater than or equal to 7. Done. Right? Just look at the graph and see where the graph goes. I mean, it's a little tricky because, you know, these wolves probably had a population before 1995, but what we were given seems like started in 1995. Okay. That is it. I mean, most of this lesson is really just introducing function notation. It will come up. It will come up. There's always at least one question on the SOL, which is find f of a number, and then they're going to give you some expression to fill in. It shouldn't be that much more difficult than evaluating any other expression. So that's the homework for tonight.